The next method we're going to learn is called substitution. And what we're going to do here is for one of the equations, we're going to solve for a variable, and we're going to substitute in for that variable in the other equation. Okay? Now, so our first equation here, system of equations, we have x plus 6y equals 3, and 7x minus 4y equals negative 25. It's nice to pick, for the variable that you want to solve for something that doesn't have a coefficient in front of it, if you can, or has a coefficient of 1. So here we just have x. So we're going to solve for x here. So we're going to take the equation x plus 6y equals 3, and we're going to subtract 6y from both sides. So we get x by itself pretty easily. We say x equals 3 minus 6y. Now what we want to do, we want to plug in what x is equal to in for x in the other equation. And we're going to put parentheses around it so that we remember to distribute. So we're going to have 7, we have 7x minus 4y equals negative 25. So we're going to 7 for the x, we're going to put in what we just solved for x, 3 minus 6y, close the parentheses. Now we'll write the rest of that equation, minus 4y equals negative 25. And now this is just a linear equation with one variable, so we're going to solve for y. So we'll distribute our 7. So 21 minus 42y minus 4y equals negative 25. I'm going to combine these like terms. So 21 minus 46y equals negative 21. Now I need to subtract 21 from both sides. Oops, this should have been 25. Okay. Sorry, I ran out of room, so I'm going to come up here. So I have negative 46y equals negative 46. So I'm going to divide both sides by negative 46. And here we see that y is equal to 1. Okay, so that's our y coordinate. Now we need to solve for x. Well, we already have an expression, an equation where x is equal to something in terms of y. So we can use that to find x. We know x is equal to 3 minus 6y, and we know that y is 1. So x is equal to 3 minus 6 times 1. So x is equal to negative 3. So our solution to this problem would be negative 3, 1. So you always put your x and your y just like a point. Okay, in this next equation we have negative 4x plus 5y equals 40, and 8x plus y equals negative 14. Now, there was nothing that said we had to solve for x in the previous one. And here we have a y that'll be pretty easy to solve for. So we're going to start with the second equation, 8x plus y equals negative 14. And we're going to solve for y. So we're going to subtract 8x from both sides. And we'll get y equals negative 8x minus 14. Now we need to plug that into the other equation. So that's equation number 1. So let me write that, negative 4x plus 5y equals 40. So we're going to plug in what we just solved for y in with parentheses, so negative 4x plus 5 times negative 8x minus 14 equals 40. So I'll distribute this 5. So negative 4x, and then we'd have negative 40x. 5 times negative 14 is negative 70 equals 40. So I'll combine my like terms here. So negative 44x minus 70 equals 40. Now I want to add 70 to both sides. So I get negative 44x equals 110. Okay, now I need to divide both sides by negative 44. Okay, here we get a decimal. We can change that into a fraction if we want and say, okay, that's negative 5 halves. So we're going to say our x is equal to negative 5 halves. Now we need to plug that in to find y. So we had this equation for what y was equal to. So we have y equals negative 8 times negative 5 halves minus 14. And if you want, you can put that whole thing in your calculator. Negative 8 times negative 5 halves minus 14. And y is equal to 6. So our solution here is negative 5 halves 6.